All right, welcome back to 6.5 part 2, where we're going to look at two more examples. These ones, we're still trying to find an exponential function to describe the situation, but with these two examples, it's a little bit more complicated. We're given a different kind of information, or it's asking for a different kind of question. Um, so let's look at this example 3 here. An account growing at a constant percentage rate contains $50,000 in 2004 and $8,000 in 2014. Let's find its annual growth rate, which you usually write as a percentage, and also express the account balance as a function of the number of years, t, since 2000. So number of years since 2000 is what's a little different here. So in 2004, how many years since 2000 is that? That would be t equals 4. 2014 is going to be, how many years since 2000 is 2014? That would be 14 years since 2000. So what we're given is, in other words, f of 4 equals 5,000, excuse me. And also f of 14 is the 8,000. Okay, so it doesn't say what it is in year 0. That would year t equals 0 would be the year 2000. So we don't have the starting amount. So looking at the different formulas you could use here, the A for all of these ones tell you what the output would be in year t equals 0. But we don't have that here. So we're going to have to use this last one that says f of t equals a times b to the power t minus t0. It starts at a when t equals t0. That's what, if we think of the starting year for our problem as t equals 4 instead of at t equals 0, then that's that value of a. So I'm going to plug in t0 equals 4, that's the beginning year, and a equals 5,000 into that formula. So 5,000 for the A, and it's times B to the power t minus 4. And if you want to check that this works, if you plug in t equals 4 here, the exponent is going to become 0. So you'll get b to the power 0 there, which is 1. So that makes the result just 5,000 times 1, which is just 5,000. So that works. Okay. So yeah, but just like the other problems, like example 1 and 2, we don't know the value of b. This isn't a complete formula yet. So to find b, we can use this other fact. If we plug in t equals 14, make the result be 8,000, we'll have a formula that just has the b in it that we want to find. So we're going to do 14 minus 4 as the exponent, and the result should be 8,000. So let's see, if we want to find b, we can divide both sides by 5,000. That's going to give you b to the power 10. I'm just simplifying 14 minus 4 there. 8,000 divided by 5,000 comes out to 1.6. And then if you want to cancel out the exponent 10, you could either do a 10th root of both sides. And because that's an even number, it's got to be a plus or minus a 10th root on the other side. However, we know that b is always, it needs to be a positive number for exponential functions, so we're just going to use a positive one anyway, so I'm going to drop that. And the usual way to actually calculate this is, of course, with a fractional exponent. The exponent 1/10 means the same thing as a 10th root. So that's what I'm going to calculate here. And I get 1.04812 about. Okay, so that is the value of b. We can plug that into the original function now. $5,000 times 1.04812 to the power t minus 4. And that's basically the answer to the question. It's also asking, what is the annual growth rate? I haven't quite found that out. The annual growth rate is always going to be what the r is when you write the b in the form 1 plus r. So in this case, that's 1.04812 is the b. And if that's 1 plus r, you can just subtract 1 to get r, and you get 0.04812. And as a percentage, if you move the decimal place over 2 spots, that gives you 4.812%. Okay, so that's that one. It's a little tricky, got some extra layers in it. Example 4 also has some extra layers. I don't remember where I got this problem from. I think I got it from the textbook when I wrote these notes. And I looked it up just because I was curious, because I thought it was funny that there was this element called hafnium, which has a half-life of 12.2 hours, which is 1/2 of a day. So did they name it hafnium because its half-life is 1/2 of a day? So I looked it up on Wikipedia here, and what I discovered was that hafnium is a radioactive element that actually has a bunch of different isotopes, which means like the, what are they called? The nucleus of the atom can have different amounts of neutrons in it. And there's all kinds of different hafnium. And a lot of them are stable for many, many years. So they have very long half-lives. And then I found the one that this problem came from that had a half-life of 12.1 hours, is I think what this was based on. So hafnium 171 is the particular isotope that has a half-life of 1/2 of a day here. So I'm going to correct that here. It's specifically hafnium, what was it, 171. Has a half-life of 12.2 hours. Other kinds of hafnium have totally different half-lives. Anyway, so if you begin with 1,000 grams of hafnium 171, a kilogram, let's write a formula for the amount you have A of t after t hours. And let's see, when will you have 250 grams? So to write this formula, the formula, well, we have the starting amount and we have the half-life. Let's go back up to the formulas at the beginning. Which one of these do you use if you know the half-life and the starting amount? Oh, this one looks perfect. The half-life is h. In this case, that's 12.2 hours. So every time t increases by h, the output is cut in half, is what we want to have happen here. And the beginning amount is still going to be A. So this is going to be 1,000 grams is the A. It's going to be times 1/2 to the power T divided by 12.2. And So yeah, that's basically the formula. The other part of the question is when will you have 250 grams? Okay, so to figure that part out, this is the harder part of the problem. We're saying the result, the amount, is 250, but we don't know, the when is what we don't know. So that's how much time does it take to get that. So I'm going to write the formula for A of t as 1,000 times 1/2 to the power t over 12.2. So this is the equation we want to solve to try to find t. Now there's a few ways you could do it. You could do this on Desmos. You could just graph y equals 1,000 times 1/2 to the power t over 12.2 and also graph y equals 250 and see where they intersect. I'm going to go through the analytical way because I think that's a little bit more interesting here. So if you're trying to get t by itself, well, you can start by canceling out this 1,000 because it's multiplied there. You can always undo multiplication by division. So that's a straightforward first step. And 250 divided by 1,000, if you just reduce that, you'll get 1/4. And 1/4 is also known as 1 over 2 squared. It's half of 1/2 is a quarter. So I'm just going to rewrite this over here. But instead of 1/4, I'm going to write it as 1/2 squared. This is the same thing as this. And I wanted to do that because that was the method that we looked at in section 6.4, where if you can make both of these sides of the equation be 1/2 to a power, and what we're trying to do is find out what t makes this true, what really makes them equal, it's going to be whatever t makes the exponents the same. So t divided by 12.2 should be equal to 2 here. To make both sides of this equation equal. So now you can just multiply both sides by 12.2. You get 24.4. So this might sort of make sense in the context of the problem, is that if the half-life is 12.2 hours, how long does it take to reduce by half twice? That's what you have to do. If you have 1,000 grams, half of that is 500. Half of that again is 250. So that's what this is doing. It's reducing by half twice, and it takes 2 half-lives, 2 times 12.2 hours. So maybe that makes sense. I should be including units here, which I always say, but I forgot to do. That's 24.4 hours. Okay. So there's the answer to that question. All right, so next you have some exercises which are pretty similar to these examples. You're going to try to write formulas for the functions that you're given, either using a table or a graph, or exercise 2 here has a doubling time. So give those a shot. I'll show you the answers if you get stuck or you just want to check your work in the next video.